Hello everyone, welcome back to the channel. Today we're going to dive deep into an interesting and detailed comparison between two of the most advanced medium-range missile defense systems in the world right now, Israel's Barak MX and Russia's Buk-M3. Both of these systems represent cutting-edge military technology and are designed to protect against a wide range of airborne threats. Each has its own philosophy, design approach, and combat role. And understanding how they compare gives us a good sense of how modern air defense technology has evolved. The Barak MX is developed by Israel Aerospace Industries and is considered one of the most flexible and modular air defense systems available today. It's part of Israel's layered defense strategy that includes systems like Iron Dome, David Sling, and Arrow. The Barak MX is intended to provide a medium to long-range shield against aircraft, helicopters, cruise missiles, drones, and even ballistic missiles. What makes it stand out is its modular design, meaning it can be configured according to the needs of the operator. It uses different interceptors, Barak MR, LR, and Arrow that can engage threats from a few kilometers away all the way up to around 150 kilometers for the extended range version. The system also emphasizes integration and adaptability. It can be deployed on land or sea platforms, which makes it very versatile. The same core technology is used on Israeli Navy ships under the name Barak MR. This naval version has already seen real-world action, intercepting drones and missiles in recent conflicts. The Barak MX also features advanced radar systems capable of tracking multiple threats simultaneously and launching interceptors accordingly. Its command and control system is digital, network-based, and designed to communicate easily with other defense assets in a layered network. This kind of integration is essential for modern warfare, where information and timing can decide the outcome of engagements. On the other hand, the Buk-M3 represents Russia's latest evolution of its long-running Buk surface-to-air missile family. The Buk line started in the Soviet Union during the 1970s, and over the years it has been continuously upgraded. The Buk-M3 is a highly mobile, self-propelled, medium-range air defense system designed to protect moving military units or fixed installations. It can engage aircraft, helicopters, cruise missiles, tactical ballistic missiles, and drones. The Buk-M3 uses the 9R-31M missile, which has an engagement range of around 65 to 70 kilometers and can reach targets flying up to about 35 kilometers in altitude. Its launcher vehicle carries up to 6 ready-to-fire missiles and can track dozens of targets simultaneously. Mobility is a key feature of the Buk-M3. The entire system is mounted on tracked vehicles that allow it to move with armored units or reposition quickly after firing. This makes it difficult to target and destroy, especially in high-intensity conflicts where air defense units are constantly hunted by enemy forces. The system also has modernized radar and fire control components, allowing it to operate effectively in environments with heavy electronic jamming. Its high degree of autonomy means each launcher can act independently or as part of a larger network. When we compare the two systems, the first major difference that stands out is the operational philosophy. The Barak MX is built for integration into a multi-layered defense network and emphasizes flexibility and modularity. The Buk-M3, however, focuses on mobility and self-sufficiency for frontline operations. The Barak MX can form part of a national air defense grid, while the Buk-M3 is designed to move with the army and protect mobile formations in real time. This difference shapes almost every technical aspect of each system. In terms of range, the Barak MX has an edge. Its extended-range interceptor can reportedly engage targets up to about 150 kilometers away, which gives it a broader protection zone. The Buk-M3's range of around 70 kilometers is respectable for its class but remains smaller. The Barak MX's interceptors are also optimized for both aerodynamic and ballistic targets, while the Buk-M3's missiles, though capable of intercepting ballistic threats, are more focused on aerodynamic targets like aircraft and cruise missiles. When it comes to sensor and command capabilities, both systems employ advanced radar and data link technologies, but their configurations differ. The Barak MX operates through a central battle management system that coordinates radar data and interceptor launches across multiple batteries. It can also integrate with other Israeli or NATO systems. The Buk-M3, on the other hand, can function either as a coordinated unit or autonomously. Each launcher can detect and track its own targets, which provides redundancy if command links are disrupted. This makes the Buk-M3 especially suitable for battlefield conditions where communication networks may be degraded. Another point of contrast is mobility. The Buk-M3 clearly takes the lead here. Its tracked vehicles are designed to move across difficult terrain, set up quickly, and fire on the move if necessary. The Barak MX is mobile too, but it relies mostly on wheeled launchers and is often deployed in semi-fixed defensive positions or at naval installations. The Buk-M3's focus on movement makes it a true tactical system, while the Barak MX is more of an operational or strategic layer defense system. Now let's talk about combat experience. The Barak MX system and its variants have already been used by Israel in real combat situations, particularly in defending against drones and cruise missiles launched by hostile forces. Reports indicate successful interceptions both on land and at sea, demonstrating reliability under fire. The Buk-M3 has also been deployed in real combat by Russia, notably in the ongoing conflict in Ukraine. It has been used to intercept aerial targets, though there have also been reports of Buk-M3 systems being destroyed by precision strikes, which shows that no system is invincible in modern warfare. Still, its use in an intense combat environment provides valuable data on its strengths and weaknesses. In terms of export and international presence, the Barak MX has been gaining significant traction. Countries such as Slovakia, Cyprus, and Morocco have signed deals or expressed interest in the system. Its compatibility with Western technology makes it attractive for NATO-aligned states looking for advanced yet affordable air defense solutions. The Buk-M3, meanwhile, has been primarily fielded by Russia, and although it has been offered for export, the current geopolitical climate and sanctions make international sales more challenging. However, some Russian allies or defense partners might still consider it for their armed forces due to its proven design and lower acquisition costs. Technologically, the Barak MX employs some of the most advanced guidance and tracking methods available. It uses active radar seekers that allow its interceptors to home in on targets even after launch without continuous radar illumination from the launcher. This makes it more resistant to jamming and allows simultaneous engagement of multiple threats. The Buk-M3 also uses active radar guidance, but its engagement process relies more heavily on the launcher's radar control. Both systems can handle multiple targets, though the Barak MX's networked fire control allows for a higher degree of coordination across batteries. From a logistical standpoint, the Barak MX system benefits from Israel's emphasis on efficiency and maintainability. Its launchers, radar units, and command modules are designed to be easily replaced, transported, and upgraded. The modular nature means new interceptors or software updates can be integrated without redesigning the entire system. The Buk-M3, while mobile and rugged, requires a more complex logistical chain because of its tracked vehicles and heavy mechanical components. Its maintenance demands are higher, which can be a factor for operators with limited resources. When evaluating cost-effectiveness, both systems target different markets. The Barak MX aims to provide a Western-grade system at a lower cost than long-range platforms like the Patriot or Aegis. It offers layered defense capability at a fraction of the cost while maintaining high performance. The Buk-M3, on the other hand, is cheaper to acquire but may have higher operational costs due to fuel and maintenance for its tracked vehicles. In terms of training and operational complexity, the Barak MX's interface is considered more user-friendly, with advanced automation and digital systems. The Buk-M3 maintains the rugged, somewhat manual operation typical of Russian designs but is built for reliability and simplicity in field conditions. The combat philosophy between the two nations also plays a role in how these systems are structured. Israel's defense doctrine emphasizes protecting limited airspace and population centers from missile and drone attacks. Therefore, the Barak MX is optimized for high-precision intercepts and seamless integration with other defensive layers. Russia's doctrine, by contrast, prioritizes large-scale mobility and protecting moving ground forces from air attacks. The Buk-M3 fits this philosophy perfectly, offering strong, mobile protection to advance in troops or strategic assets on the move. When we look at survivability, the Buk-M3's design allows it to relocate quickly after firing to avoid counterattacks. The Barak MX relies more on its ability to engage targets from longer distances, staying behind friendly lines. Both are designed to withstand electronic warfare, but Israel's system places a greater emphasis on countering smart, low observable, and high-speed threats, reflecting the types of threats Israel regularly faces. In terms of modernization potential, the Barak MX has a clear roadmap for upgrades. New interceptors and radar improvements can be added to existing systems without major redesigns. The Buk-M3, though modernized from older systems, faces limitations imposed by its mechanical design. However, its base architecture is solid and could be further upgraded with better sensors or command modules if the manufacturer decides to continue development. When analyzing combat efficiency, the Barak MX's extended range and faster intercept times offer a stronger defense umbrella over large areas. It's particularly effective for defending high-value assets like cities, power plants, or naval fleets. The Buk-M3 is designed for battlefield air defense. Its job is to keep enemy aircraft, drones, and missiles away from advancing troops. Each system performs best in its intended environment. Another important factor is radar signature and detection. The Barak MX uses AESA radars with high tracking resolution and resistance to jamming, capable of detecting small drones or low-flying cruise missiles. The Buk-M3 also uses phased array radars, but their main advantage lies in the ability to track multiple high-speed aerial targets at mid-range distances. The radar's design allows engagement in cluttered battlefield conditions but with slightly less detection range than the Barak MX's longer-range sensors. Looking at the bigger picture, both systems reflect their nation's defense philosophies and technological strengths. The Barak MX embodies Israel's focus on innovation, precision, and integration across different domains: land, sea, and air. The Buk-M3 represents Russia's commitment to robust, mobile, and heavily armed battlefield systems designed to withstand rough conditions. Both are formidable, and both continue to evolve as new technologies and threats emerge. In an actual combat scenario, the effectiveness of each system would depend heavily on deployment strategy, operator training, and the threat profile. Against swarming drone attacks or mixed salvos of cruise and ballistic missiles, the Barak MX might offer superior coordination and interception rates. In a fast-moving land conflict with frequent relocations, the Buk-M3's mobility could make it more survivable and responsive.